So, and let's go further and build the sequence of Karamba3D components. So here I have a list of with 4 branches, a data tree with 4 branches, and I've intersected also the longitudinal beams to add these pendulum columns in the middle. So from Karamba, I'm gonna need the line to beam component, the supports, joints for the short beams, let's say on the short side of the building, beam joint, and the load, of course. This is going to be a block global load, and I'm gonna collect this. So, and assembly assemble the model, analyze it, the view beam component, and I think here was the model view components, and disassemble the model and the element also. So the goal of this video will be to collect the bending moments, the values, and with some lists organization to export the data to Speckle with the components for Speckle. So let's see how we can do this. Let's say that I'm going to have a list with a data tree with 4 branches for the cross beams, for the columns, longitudinal beams, and pendulum columns, but it's up to you how you rename this. This is going to be the multi-line, and make a series to count the number of list length first, to count the number of these lists here, and this is going to be from 0 to 1, and concatenate this as and grab this. Let's see what we get. This was not right, sorry, I need to put this here. And okay, now I have first CB, the names for the beams, for the short beams, then the columns, and then so on. Is everything in the list? And this is going to be the ID. Now for the bending, I also want to assign ones and zeros. So 0 was the group with these pendulum columns, so I don't want to get any bending moments for these columns, and I have to assign a 0 there. So here are going my elements. For the supports, I need to find the points. From this component are the 6, and from C# component from the evaluate curve are the other 2. So let's merge this. Sorry, here was very important that I graphed the bending moments, so that I have again a list of 17 elements. So for the supports, let's say I want to constrain all the translations in 3 directions, and collect this one. Sorry, this was the joints. Connect this here, Maybe now I can define also the cross section, and we will see later how we can optimize this. So let's first, from the tab cross sections, I'm going to need, first I'm going to assign one type of the section, and later I'm going to optimize it. So before this I need the material. And the cross section, this is going to be assigned here in the characteristics of the elements. Let's just from item selector add 4 kind of selections for the sections for the 4 groups of elements. And for the beginning, this is going to be HEA 300, for example. I'm gonna collect this with holding shift, and now this goes here. Let's, before I assign the joints, let's make some generic load quickly of 10 value. And assign what I have till now. These are elements, and these are the supports. Okay, everything is functioning right now without the supports yet, but let's just view some results. Okay, here I have the deformation also on, and here now I can view the cross section, which is same for all of the elements, and I will see how I can optimize it. And also, if I want to show the moment diagram, I also can see that in this direction I have 2 joints, but actually I don't want to have moment in this direction, so I have this. I want this to be like a simple beam, and that's why I want to assign the joints. Sorry, this is not the right component. I prefer to make this with the other one. Yes, with the start and end position. So this is going to be the same at elements and a start and end position. And I can assign the joints here, and now this moment here also disappears. And the joints, I'm going to make them smaller. Okay, let's stay. Before I optimize the cross sections, I want to take a look at the utilization of the elements from the results, and I want to look at the values. Okay, so I can see that I have values over 1 or not at full capacity exhausted, or over 1, so I need definitely the cross-section optimization. I'm going to assign this component optimize cross-section and connect the model, the elements, and the cross-sections back here. So I'm going to use this group of cross-sections, but I need that the profiles are different dimensions, different size. So the problem was that I don't need to put here the elements but their names, so that can be organized. Yes, these are the indices, the element IDs. This is what I need, the string, and this is going to be back to model. And now I can see that I have different sizes of the beams, and back here my utilization looks like better. Here I have exactly smaller than 1. Okay, so this was from the statical point of view with Karamba3D, and now let's see how we can get the bending moments, the names, and the families, the cross-section families, and organize this in Speckle. So I'm gonna need the names in the 4 lists, and let's take this as data, and I think it was called data statistics, tree statistics. Okay, I want to reflect the data structure to other lists with the bending moments and with the name of cross sections. For example, this is gonna be the data that I want to export to Speckle. So here I have the length of every branch, 4652, and also the count. And before I disassemble the model, let's just check if the model is well constructed. So here from model, connected parts, these lines are representing my beams or columns, so everything is lines, and here is one whole list, so there are no branches or sub lists, so it means that all the elements are connected properly. So later I'm going to need these lines. First let's deconstruct the model. And from the model I need the beams. These are my elements where I can take the cross section. The cross section, it's coming from the beam. Here is the list of my cross section families. So from this statistics here, I want to use the count to partition a list with 4 branches, so to reflect exact the same structure. But which list? So these are my bending moments. Beam forces is getting the analyzed model. And now I have 2 values for each beam. So I need here first in the middle. So let's say 0.5. And then the same 3 more times at 1. And at 0, because I want to have these 3 values in the middle, at the end, and the start. And here now I have 17 values in branches. Let's just flatten it. And this is going to be my, the lists that I'm going to get with this structure. So it feels 6, 5, and 2, like here. Let's bring this here. Yes, these are my moments. Maybe also shift paths. And put this list here and put this list here. Now I have a list, and I have of course the list with the pendulum supports as zeros. Alright, now I have this data collected. Let's see what we can do now. And now I can maybe copy this and use this for the name of the... Here I disassembled the beams, and now I can get the cross-section names. of course with the same structure. So this is the list of the cross sections, and this is the corresponding cross sections. Here what else can I do is take only the name of the family. This can be, for example, with text fragment. Just write a number for the indices. Let's see how this can work. Watch the panel. For the 10th index, maybe it's good right now with the 30th index, because I'm getting only name and the name of the family from this whole string. So maybe this works for us. And I think we're getting now to the Speckle part. I have the send component, I need the data. So this is called the extend Speckle object, and I can add different properties. The first one is going to be for the members. This is going to be the key or ID, then the cross section, and the last three going to be the moment value at 0.5, at 1, and at 0. The lines are going to be the members, the keys, and the cross sections are here. Okay, so here I see the 68 elements, 4 branches with 17 members. Let's just graph this, all of them. Yes, now I have a list of 17 members with their properties. Let's just see what I will get back in Speckle. So yes, these are the 17 elements with their properties. Yes, I think I need to flatten this also. Let's send it again. Yes, now I have the list of 17 elements, and if I expand it down, I can see that I'm getting the 3 values for the elements and the cross-section name. And here in the beginning is the key. Yes, this is very useful. And if I select each element, I can get the properties also in one table separately. So this is helpful for me, and this was everything for this video. Thanks for watching. Bye.